In the previous class, we have discussed that the capacitance C is the basic scalar property of a conductor. Mathematically, we define it as the ratio of electric charge on the conductor to that of the electric potential of the conductor. See, when you give electric charge to a conductor, that electric conductor will become charged and it can acquire electric potential simultaneously. So the concept of electric potential and electric energy, that will happen simultaneously. You are giving electric charge to a conductor, it does mean that you are giving energy to the conductor, so that its potential simultaneously increases. In the previous class, we have written that the charge is proportional to the potential. So charge Q is equals to some constant C into V, or else you can write C is equals to Q by V. This is said to be the electric capacitance of the conductor. Now, to increase the capacitance, to store more electric charge, you must reduce electric potential. Suppose एक कंडक्टर का कैपेसिटेंस आप इंक्रीज करना चाहिए, तब आप क्या करना पड़ेगा? आप उसका पोटेंशियल कम करना चाहिए. पोटेंशियल एक गर्व जैसा हो सकता है. अगर आप I need to say example you me. If I reduce my pride feeling, if I reduce my गर्व, then I can learn more. So usually when we are learning something, because of learning also we get the pride feeling. So if we do not have pride feeling, and if we are down to earth, then we can learn many more things and we can accept others. We can accept the greatness of the others. So to learn, one should have a basic quality of not having pride feeling. That's why obedience, this word came. So a good learner is always a good teacher. So a teacher need to learn continuously and carefully without having a pride feeling. So you can compare that pride feeling with the potential. When you are learning something, your pride feeling also will increase. So when you are charging a body, automatically its potential also increases. But if you want to learn more and more, you need to reduce the pride feeling. Similarly, if you want to charge a conductor more and more, if you want to store more and more charge, then you need to reduce its potential. Automatically, what happens? Its capacitance is said to be increased. Dear students, already in the previous classes I told, capacitance of a given conductor is dependent on two things. Number one, its dimensions, and number two, the surroundings. So surroundings also play a major role. So in the previous session, I have discussed a combination of two concentric conducting shells. See, in this I am taking the same example. Here I have taken a conducting shell A and another conducting shell B. Both I have taken concentrically. O is their center, common center. A has radius small a, whereas the radius of B is small b. Now, if you are earthing one of the conductor, my dear friends, you can earth any conductor. First of all, I will show by earthing the conductor B. I am earthing the conductor B, whereas the conductor A was given some positive charge plus Q. This positive charge resides on the outer surface of A and the inner surface of A has no charge. Because of electrostatic induction, the same amount of negative charge will be induced on the inner surface of B. The inner surface of B will have same amount of negative charge. So this negative charge is minus Q. You know, my dear friends, here I want to write outside same amount of positive charge will be induced, that is plus Q. But as this is connected to ground, from ground the electrons will go, so that these positive charges which are present on the outer surface of B, they disappear. They will be neutralized because of the electrons that are flowing from the ground to this particular conductor. Which one? B. Now there will be electric field between A and B, and there will be electric potential difference between A and B. Now dear students, if you write the potential of A and B, potential of B is 0, whereas potential of A, if you are writing potential of A, if you write because of its own charge, that is 1 by 4 pi epsilon naught charge on A divided by radius of A, plus 1 by 4 pi epsilon naught charge in its surroundings, that is on the inner surface. How much charge is present on the inner surface of B? There is minus Q. So minus Q upon B. So if you are calculating the potential difference between these two, that is BA minus BB, if you write, you will be getting Q upon 4 pi epsilon naught common 1 by A minus 1 by B. In this manner, you are likely to get the potential difference between the two conductors. After writing the potential difference between the two conductors, dear students, you are able to write the capacitance of this particular arrangement. Capacitance of the arrangement is said to be C is equals to charge on the higher potential plate or higher potential surface. Can you tell me which is higher potential? Here B is low potential, whereas outer surface of A is high potential. High potential to low potential, the electric field is directed. So dear students, the energy is provided between A and B, that is from high potential to low potential. Always when you are writing this capacitance, you must remember that this Q is the charge on high potential plate inner surface. So if it is a parallel plate capacitor, then you must write charge on high potential plate inner surface. So if you are taking parallel plate capacitor, then Q is said to be the charge on high potential plate. But which side you need to take? Inner surface you need to take. Here if you consider in this arrangement, high potential is A and the charge is present only on outside of A. So obviously we take that charge only, that is plus Q. So I am not writing positive sign here, and it divided by the potential difference. Potential difference between A and B, that is B minus BB. B minus BB is nothing but BB anyway 0. So you are going to get the capacitance C is equal to, you can write Q upon Q by 4 pi epsilon naught into 1 by A minus 1 by B. Now dear students, this is said to be the capacitance of this arrangement. If you simplify further, what you are likely to get? For this arrangement, capacitance C will become this Q cut. Okay, here in the denominator part, what is that? 1 by 4 pi epsilon naught is that. That is into 1 minus A minus 1 by A minus 1 by B. If you take LCM, you will be getting B minus K divided by AB. So here it becomes 4 pi epsilon naught into AB upon, in the denominator here, B minus A So like this, you are able to write the capacitance of this particular arrangement. So capacitance, when you are writing, you must remember that capacitance is basically dependent on two things. Capacitance is independent of charge. Yes, capacitance is independent of charge. Whether the charge is present or not, that is not the criteria. See, you are at home right now. From last 3 months, 4 months, you are at home. But the capacitance of your classroom does not change. Whether you come to campus or you do not come to campus. Your classroom previously accommodated 75 students comfortably. Now also it can accommodate 75 students. Its capacitance does not change. Similarly, if you take big room in our college campus, it may accommodate 150 to 160 students comfortably. Like that, its capacitance is also constant. So how a classroom, with the presence of students or without the presence of students, can have certain capacity. Likewise, how a hall or auditorium, a cinema theater, how it can have some seating capacity. How these capacitances are independent of the audience or students. Likewise, here also, the capacity of this arrangement is not dependent on charge. See, interestingly, C is not dependent on charge. Here charge is not there. Maybe in this equation it is there. So by saying this, you don't misunderstand. Capacity of a given conductor dependent on charge and proportional to charge. Don't think like that. Whether charge is present or charge is not present. I am telling you again. From last 4 months, the aeroplanes are vacant. But the seating capacity is constant. Each aeroplane, very smaller one, between our domestic cities. If aeroplane takes off, crew members plus passengers together, 80 members will be the capacity. So likewise, aeroplane capacity is constant. Whether it flies, whether it takes passengers or not, its capacity constant. So capacity is independent of passengers. Capacity of a room is independent of people or persons. Capacity of particular land is independent of people. The people may present or not. That is secondary. But capacitance is always constant. Similarly, capacitance of a conductor is independent of presence of charge on it. Suppose if it is able to accommodate more charge, you can say that it has more capacity. Okay. But basically, capacitance is not dependent on the presence of charge. So capacitance depends on two things. Here, this if you observe 1 by A minus 1 by B, or if you observe this as AB by B minus A, these are set with the radius. So think over regarding that. This mathematical part indicates that dimensions. Dimensions go with the size and shape of the conductor. So the dimensions of the arrangement will decide the capacity. Okay, and not only the dimensions but also the surroundings. Here 4 pi epsilon naught is there. Epsilon naught indicates here free space or air medium. So if you change the medium, automatically capacitance will change. My dear students, you know epsilon naught is permittivity of a free space or air. Okay, so if you introduce a dielectric, automatically here comes epsilon. So if you put some dielectric, the spark will become epsilon naught is to be replaced with epsilon. So automatically this epsilon, again we can write as epsilon naught, epsilon r. Like that we can write. So the presence of medium between the high potential surface and the low potential surface, that will also decide the capacitance. Okay, fine, what is the reason? This epsilon r value is the dielectric constant. That is dielectric constant, other name is relative permittivity. Okay, or it is dielectric constant or relative permittivity, or it is, yes, specific inductive capacity. So that epsilon r is a positive value and greater than 1 for all dielectrics. What are the dielectrics we are having in our surroundings? They are having plastic, they are some mica, okay, some cotton. You can take any material which is a non-conductor. Such dielectrics have the epsilon r value dielectric constant greater than 1. So such higher values, if you substitute in this, obviously capacitance will become those many times, multiples. So capacitance of the arrangement basically dependent on dimensions and the surroundings, but not the presence of charge. Yes, I repeatedly say, remember this, repeatedly I am saying, if a body or a conductor can store more charge, then its capacity is said to be more. Good. Next, if you want to do that, if you want to store more and more charge, suppose if you want to learn more and more things, how you need to control your pride feeling? In the same manner, here, to increase the amount of charge on a body, we need to reduce its voltage. See my dear friends, I really feel very happy to be here in this great land. The reason, from last 6 years I am observing so many batches, especially IIT JEE students. Many of them are coming from various sectors of the society, but I am observing a common quality in everyone. Whenever some meeting takes place in our campus, in our college, usually parents never wait for a chair or something. They come and sit on the floor. Whether the parent is working as an engineer, or he may be a doctor, or he may be a business magnate in the society, whoever they may be, the respect grows. They come and sit on the floor, on the carpet. So they are very down to earth. Like that, when we are down to earth, when we don't have high potential, then obviously our potential whenever less, then we can acquire more and more charge. See, anyone's obedience in front of elders will take them to the highest heights in the life. We are observing so many role models around us like that. So they will be said to be having more content in them, but less potential. So they are said to be having more capacity to handle the things. Okay, more content, less potential. It is said to be having more capacity. Usually it happens when charge is increasing on a body. Potential of the body also said to be increasing. If you want to store more and more charge, what is to be done? If you want to increase the capacity, what is to be done? You need to store more and more charge. Further, you need to reduce the potential. That's what we did here. Capacity, what is to be done? You need to store more and more charge. For that you need to reduce the potential. That's what we did here. Okay. Now we go for another combination, my dear friends. In this combination, what I would like to take is the same concentric spherical shells. But now what I want to do, let us see. This is said to be a pair of or a combination of concentric spherical shells, say A and B, with radii small a and small b respectively, with the common center from the common center O. Now I would like to give charge to B. Say I am giving some positive charge plus Q to B. And I am not giving any charge to A, rather than I am connecting the inner shell A to ground. So I am connecting A to ground like this, as shown in the figure. So when I do like this, immediately you get it out. Sir, inner surface there is no charge in a cell. How capacitor will be formed? Say, dear students, here inner surface of B. Imagine having a charge Q, and this surface of A is said to be having a charge Q will be formed. Say, dear students, here inner surface of B, imagine having a charge Q, and this surface of A is said to be having a charge Q dash. What is the charge? What is the charge on the outer surface of A? Q dash. What is the charge on the inner surface of B? Small q. What is the remaining charge on the outer surface of B? Q minus small q. Now let us find out the charges first. How to do that? We can do like this. See, if this is A and this is B, okay, I call this as A, I call this as B. First of all, I would like to take the Gaussian surface through A. This is said to be Gaussian surface through A. So I am writing over here my steps. Gaussian surface through whom? Through A. If I take Gaussian surface through A, it does not enclose any net charge. So outside charge Q dash, here charge small q, here Q minus small q. Okay, if I take Gaussian surface through A, net charge enclosed by A is 0. So inside of A there will be no charge. Now I take the same Gaussian surface through B. Here, what is the shape of the Gaussian surface? Can you imagine? The shape of the Gaussian surface is sphere. Okay, so I am writing the same here. Gaussian surface through Gaussian surface is sphere. Charge through A. If I take Gaussian surface through A, it does not enclose any net charge. So outside charge Q dash, here charge small q, here Q minus small q. Okay, if I take Gaussian surface through A, net charge enclosed by A is 0. So inside of A there will be no charge. Now I take the same Gaussian surface through B. Here, what is the shape of the Gaussian surface? Can you imagine? The shape of the Gaussian surface is sphere. Okay, so I am writing the same here. Gaussian surface through B. If I take Gaussian surface through B, it encloses no net charge. This is the condition. So dear students, according to the previous lectures, Q plus Q dash is equals to 0. So here I can write as Gaussian surface taken through a conductor does not enclose any charge. I have taken Gaussian surface through A, it is not enclosing any charge. Similarly, I am taking Gaussian surface through B. That should also not enclose any charge. So Q plus Q dash is equals to 0. So dear students, Q dash is equals to minus Q. I can write it like this. Okay, and now A is connected to ground. So what is the potential of A? The potential of A, if I write, here I am writing, potential of A is 0. Potential of A is VA, that is equals to how much beta? 0. Why? अगर आप किसी को ग्राउंड को कनेक्ट किया तो उसका पोटेंशियल क्या होगा? 0. Why you may ask, sir? Why earth the potential is 0? Think, my dear friends, feel this as earth. This is radius of earth, capital R. How much? 1 by 4 pi epsilon naught. Q by R is the potential. So this radius is how much? 6,400 km. Now for the surface, potential at the surface. If you are writing potential at the surface, how much? It is 1 by 4 pi epsilon naught. Q upon R. बेटा बताइए 1 by 4 pi epsilon naught की वैल्यू क्या है? 9 into 10 power 9. R वैल्यू क्या है? 6,400 km. So if you simplify this, the potential R is very very high. So obviously the potential that is present or that is possessed by the earth on its surface is said to be tending to 0. That's why potential of ground is said to be 0. So potential of A is 0. So potential of A अगर आप लिखा तो potential of A किसकी वजह से आएगा? देखिए बेटा, किसी को potential किसकी वजह से आएगा? Because of its own charge on its and the charge in its surroundings. So A का potential, right here, potential of A, if you write, that is 1 by 4 pi epsilon naught Q dash by A because of its own charge. And what is the charge in its surroundings? Anyway, inner surface of BQ, outer surface of B, Q minus Q. So A क्या होगा? टोटल चार्ज क्या है? B के ऊपर टोटल चार्ज क्या है? कैपिटल Q. So इसकी वजह से what is the potential of A? That is 1 by 4 pi epsilon naught capital Q divided by B. This is equals to 0. Now, dear students, if you simplify this, you are able to find out Q dash. What is Q dash? So here you can write Q dash is equals to K on either sides get cancelled. It becomes minus A by B times of capital Q. That implies what is small q? बेटा small q बनेगा minus q dash. So small q क्या बनेगा? A q by B बनेगा. This is small q, this is q dash. ये दो वैल्यूज आपको मिला तो आप यहाँ लिख सकते हो बेटा आसान से A q dash के बदले आप क्या लिख सकते हो? Minus A by B times of capital Q. So on the surface of A, which charge do you expect beta? Negative charge. How much magnitude? Minus A q by B. That much negative charge. So beta आप बताइए how much positive charge will be there on inner surface of B? Correct. On inner surface of B, that much positive charge will be there. How much? How much? That is A by B times of capital Q. So here A by B times of capital Q. So beta I want to erase Q dash here. Q here, Q minus Q here. What is the outside charge now? Outside charge. It cannot be plus Q now. Outside charge is only just positive charge. That is how much? The positive charge on the outer surface of B is having a magnitude that is Q minus Q. That is Q into 1 minus A by B. This is the charge on the outer surface. Whereas the charge on the inner surface is yes AQ by B. Charge on the outer surface of A minus AQ by B. समझ लगा? So ऐसे चार्ज का डिस्ट्रीब्यूशन हो सकता है. ऐसे चार्ज का डिस्ट्रीब्यूशन हुआ तो इसका कैपेसिटेंस क्या होगा? कैपेसिटेंस हम लिखेंगे बहुत. कैपेसिटेंस क्या हो सकता है? कैपेसिटेंस C is equals to for this arrangement कैपेसिटेंस C is equals to Q by B. Q by V. We write usually Q by V. That is general formula. Here Q का मीनिंग क्या है? Charge on the कैपेसिटेंस C is equals to for this arrangement कैपेसिटेंस C is equals to Q by B. Q by V. We write usually Q by V. That is general formula. Here Q का मीनिंग क्या है? Charge on the high potential inner surface plate. So charge on the higher potential. Which is higher potential? A is higher potential और B is higher potential. बेटा B is higher potential. Higher potential वन का inner अगर आप देखा तो ये है inner surface. Inner surface के ऊपर चार्ज क्या है? वो क्या बनेगा? That is small q. Small q value is AQ upon B divided by potential difference. What is the potential difference between A and B? आप बताइए potential of B बता सकते हो? Can you tell me the potential of B? I know potential of A that is 0. Potential of B बताइए. Potential of B VB क्या बनेगा? Because of its own charge 1/4 epsilon naught Q by B. Because total charge is Q by B ना. Of course on outer surface Q times of 1 minus A by B. On the inner surface AQ by B. On the inner surface what is the charge? On the inner surface AQ by B. On the outer surface Q times of 1 minus A by B. Okay. Now what is the total charge on the B, on the conductor B? Whether it is inner or outer, total charge is KQ. Total charge is Q. So total potential of B because of its own charge that is KQ by B plus because of charge enclosed that is 1/4 epsilon naught. How much charge it is enclosing? Minus A by B times of Q. So here I write minus A by B times of Q divided by enclosing ना B. अब देखिए आपको समझ में आएगा होगा. अगर only conductor B है, only B है, B के ऊपर चार्ज Q है, then what is the potential of B? आराम से सोचिए 1/4 epsilon naught charge on B divided by its radius. लेकिन ये A को enclose किया और ये क्या है? एक कंडक्टर है, उसका रेडियस कम होने दो, लेकिन उसको enclose किया गया और ये को हम ग्राउंड को कनेक्ट किया. अगर किसी ना किसी चार्ज कंडक्टर के आजू बाजू में राइट दूसरा कंडक्टर अर्थ को कनेक्ट करके हम रखा तो ऑटोमेटिकली पोटेंशियल ऑफ द गिवन कंडक्टर विल डिक्रीज. अभी द सेम हुआ ना. क्या हुआ यहाँ? हियर द पोटेंशियल ऑफ बी रिड्यूस्ड. व्हाट इज द पोटेंशियल ऑफ बी विदाउट ए? 1/4 epsilon naught Q by B. लेकिन ए हम लिया, ए की वजह से पोटेंशियल ऑफ बी क्या हुआ? 1/4 epsilon naught Q by B माइनस 1/4 epsilon naught A Q by B square. सो पोटेंशियल ऑफ बी कम हो गया. अभी आप देखिए capacitance for this arrangement if you are writing then C is equals to charge on high potential body inner surface. You may ask sir why are you saying charge on the inner surface of high potential body? थोड़ा सोचिए आप इलेक्ट्रोस्टैटिक्स के बारे में. यहाँ से इलेक्ट्रिक फील्ड इंफिनिटी तक जाएगा, ये सरफेस से इलेक्ट्रिक फील्ड इंफिनिटी तक जाएगा, यहाँ से सरफेस से इलेक्ट्रिक फील्ड इंफिनिटी तक जाएगा. सो यहाँ इलेक्ट्रिक फील्ड का एनर्जी डेंसिटी बहुत कम है बिकॉज फील्ड इज टेंडिंग टू इंफिनिटी, फील्ड डेंसिटी टेंड्स टू 0. लेकिन यहाँ देखिए B एंड A के बीच में ये लोअर पोटेंशियल, B हायर पोटेंशियल, एनर्जी और फील्ड डायरेक्टेड फ्रॉम इनर सरफेस ऑफ B टू द आउटर सरफेस ऑफ A. So what is the direction of electric field? अगर आप देखा तो direction of electric field ऐसे है बाबा between B and A. So here energy density is very less. Sorry, energy density is very high and thickness is very less. Separation is very less. So energy density is very high. So inner surface of B is like higher potential and outer surface of A behaves like lower potential. Only we need to write charge on the high potential plate. So what is the high potential surface here? Inner surface of B. How much charge it is possessing on the inner surface? That is AQ by B divided by potential difference between B and A. That is VB minus VA. Anyway VA potential of A is 0. So I write here AQ by B whole divided by, here what will come common? Let us take common KQ by B common because potential of B if you take KQ by B common. So here you will be getting 1 minus, here 1 minus KQ by B came. So 1 minus A by B will be here. So Q by B cut in the numerator and denominator. So final step, what is the potential? Sorry, what is the capacitance? that is A upon K into 1 minus A by B. This is said to be the capacitance of this arrangement. So dear students, capacitance किसके ऊपर डिपेंड हो रहा है? अगर आप देखा तो आपको अभी समझ में आएगा. Capacitance is basically dependent on whom? It is dependent on, capacitance is dependent on, right? You can speak. Capacitance is dependent on dimensions. Capacitance is dependent on surroundings. See, here I am writing K means what? 1 by 4 pi epsilon naught. So again 4 pi epsilon naught will go to numerator. Okay? So in this manner, you are able to understand regarding the capacity of the conductors and the arrangements. बेटा और एक बार मैं see, here I am writing K means what? 1 by 4 pi epsilon naught. So again 4 pi epsilon naught will go to numerator. Okay? So in this manner, you are able to understand regarding the capacity of the conductors and the arrangements. बेटा और एक बार मैं repeat कर रहा हूँ. If you want to write capacitance formula, the formula for the capacitance C is equals to what you need to write? Charge on the high potential plate. High potential plate or surface. Which surface? High potential inner surface. You need to write inner surface upon the potential difference between the surfaces. Okay, so charge on the high potential inner surface. हाई पोटेंशियल प्लेट का इनर सरफेस पे जो अमाउंट ऑफ चार्ज है वो न्यूमरेटर में लेना चाहिए, डिनोमिनेटर में पोटेंशियल डिफरेंस बिटवीन द सरफेसेस लेना चाहिए, तब आपको मिलेगा कैपेसिटेंस. ओके.